Officially being recorded right now, so it's got to be quiet, guys. So we are going to today talk about factoring out the greatest common factor. We're actually going to talk about finding, the greatest common factor. And if I have enough time, I'm also going to talk about how to factor the greatest common factor out of an expression. All right. This is it's ironic. I just taught this today to the 8th graders, almost the same thing, but I taught it to them last year too, but I'm doing it for them because we're moving into something more complicated very quickly. So Kara and Emma, okay? So finding the greatest common factor. The GCF is often what people, they'll often say, find the GCF. That means greatest common factor. Every now and then you'll see somebody use the word, or the phrase GCD.
Greatest common denominator.
Well, no. It would be in that case but you're right. But this would be considered the greatest common divisor, and divisor is the same as factor, right? It's just a different term. Like if you go to Khan Academy, some of you guys know Khan Academy.
Yeah.
He teaches it as greatest common divisor, not greatest common factor. Honestly, I've never seen it that way other than in his book. I mean, on his thing. So I don't know why he didn't choose this term, but it doesn't matter. It's the same idea. A factor is a number that divides into another number, right? So but anyways, so right now what I want to do is I want to find the greatest common factor. Before I go into this, I first want to talk about finding greatest common factors with numbers. Let's say I wanted you to find the greatest common factor between 16 and 48. Do you guys remember how to do this?
Mm-hmm.
How did you raise your hand? Let me know how people did this.
So you have the 16, and you find out what
Hang on
numbers
1 second.
multiplied together equals 16. And then you draw like a branch, and then you put. Okay, I'm just gonna go for example 4 times 4.
Okay, so 4 times 4. Okay.
And then from there, what goes into each of those? 2 times 2, and then you circle the prime numbers.
Okay, those are prime numbers. Right? So,
Yeah,
so you're saying to me, I just want to clarify, you're telling me that 16 is equal to 2 times 2 times 2 times 2?
Yeah.
Is that what you're saying? That's so funny. I can't believe you think. Wait a minute. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16.
Ha!
Oh my God. He's right. Okay, let's try this one. Okay, Mr. Know-It-All. Okay, now, yes.
Well, you've got 6 and 8.
6 times 8 is 48. That's the way I always remember that one. Okay,
And
what's 6 times
3 and 3, and 3 and 3 is
3 and
3 times 2. 3 and 2, and they're both prime.
3 times 2, those are both prime. And what about this one? 4.
8, yeah.
4 times 8?
2.
4 times 2.
And then 2 and 2.
2 is prime.
4.
And 2 and 2. Wait, now you're trying to tell me that 48 is the same as 3 times 2 times 2 times 2 times 2?
Yes.
Correct.
Come on. 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 24. 24 times 2 is 48. You're right. All right, so how do I find my greatest common factor?
You circle the one that's
You go.
All right, wait. End it.
You look at all of your numbers and you pick out the ones that are common for both of them, like both sets of numbers.
Okay.
So both of them, only one of them has a 3, so you can't use the 3. But both of them have 4 2s.
Oh, look, there's 4 2s. There's 4 2s there, and here are 4 2s here, right? And this one still has a 3, right?
Yeah, but there isn't a 3 in the 16.
So what is my greatest common factor then?
16.
16, right? 2 times 2 times 2 times 2, which is that? 16. So 16 is my greatest, so I could say greatest common factor is equal to 16. So how many people know this and remember this well? Right? All right, so it's pretty straightforward. What's this called, this method? Let me know. Sakara?
What? I think, isn't it called like the tree?
The factoring tree,
Yeah,
right,
the
exactly. The factor tree or factoring tree. Right. All right, so I'm going to show you a different method. Okay? That actually,
You divide and then divide.
I'm going to show you a method that is faster, okay? Because in honor of algebra, and for our guest today, algebra really is all about shortcuts. Algebra is taking everything you've learned and turning it into shortcuts, right? So algebra is about shortcuts. This is definitely a useful way. And if I'm ever confused, I will actually use this tree factoring a lot when I'm doing more advanced problems, because it really helps me to find the prime numbers. It really does help. But I'm going to show you another method.
Please don't erase it.
All right. I'm gonna just erase this then. I'll put that back. I don't even know what it was. Okay. So let's try it. Let me do it this way. 1648. I'm going to use what I call the upside down birthday cake method.
Yay.
Upside down birthday cake method. Okay? I'm not putting the method in it. And all you do is you start with an upside down birthday cake layer. Okay? And you ask yourself, what number goes into both of these?
Oh, that's what I
They're both even, right? 2 does, right? Okay, I know 2 goes into it. So I'll do that. Now I'm going to do another, whoops, wait a minute, before I do that, sorry. Now I'm going to write, okay, 2 goes into 16 how many times?
A lot.
Two.
This is how we're dividing things.
So 16 divided by 2 is 8. All right, 48 divided by 2 is 24. All right, you with me so far?
It's the weird dividing thing.
Right, it's the weird dividing thing. So now look, now I'm going to create another layer of my birthday cake. Some people consider it a wedding cake. I never get a layered birthday cake like this, but who knows? Somebody does.
Wait, but isn't it, don't you do like the smallest number that could go into them and then work your way up?
I don't have to. I can choose any number that goes into this. I'll even do it again. I'll do it again over here, and I'll choose something different, and you'll see what I mean. So, well, what goes into 8 and 24? 4 goes into both. Okay, that's fine. Let's use 4. Okay, 4 goes into 8 how many times? Twice. 4 goes into 24 how many times? 6, right? So I can always check. 4 times 2 is 8. 4 times 6 is 24. Right?
Wait.
I can always check. 4 times 2 is 8. 4 times 6 is 24. Right?
Wait, I don't.
Well, I'm just saying I can test and make sure I'm right.
No, but how did you?
8 divided by 4 is 2.
So what was the first step to doing that?
I just write the 2 numbers. And then I ask myself, what number, any number that goes into both of them. It doesn't matter what that number is. Okay? Everybody, when they first do this method, they think, oh, I've got to find the biggest number that goes in. No, you don't. You can find the smallest number, you can find the middle number, you can find any number that goes into both the terms, right? All right. Okay, now I'm going to do another layer of my birthday cake. Is there a number that goes into both 2 and 6? 2. So 2 goes into 2 how many times? Once. 2 goes into 6 how many times? 3. All right, is there any number that goes into 1 and 3?
No.
Other than 1, right? 1 doesn't ever change anything, right? Those are both prime numbers. Would you agree with me? Yeah. And there's nothing else that goes into them. So my greatest common factor is I take this, all these numbers here, and I multiply them together. 2 times 4 times 2. What's 2 times 4?
8.
What's 8 times 2?
16.
So 16, my greatest common factor is 16.
Oh.
Isn't that cool? It's a great method. It goes, so this works. This is way faster. Right? Do you see what I'm saying?
Yes.
It's a huge, huge improvement. So, and it doesn't matter. It doesn't matter what numbers you choose here. I mean, you could have said 16 goes into both, and it would have be done in one step, right? 16 goes into 16 once. 16 goes into 48 3 times, and you're done. So your greatest common factor would be 16. So let's try a couple and just sort of see if you get used to it. So let's say we have
38. Something that goes into 2.
9 and 0.
Nothing goes into
38 and 60.
64.
4. That's fine. All right, 38 and 64. I have not a clue. So All I know is that they're both even. If they're both even, what goes into them?
2.
2. All right. So 2 goes into 38 how many times? 19. Okay. 2 goes into 64 how many times?
70.
Well, 2 goes into 6 how many times? 3. 2 goes into 4 how many times? 2.
32.
Ah, now is there anything that goes into 19 and 32? No. So my greatest common factor is 2.
Yay.
Which is great. I didn't have to do this. I didn't have to do 64, 8 times 8, which is 4 times 4, which is 4 times 4, which is 2 times 2, which is 2 times 2, which is 2 times 2, which is 2 times 2. I don't have to do all that, right?
2 times 4.
Oops. Right. See? I'm just a math teacher. Right? Golly, I can't believe I did that. Okay, right? But I didn't have to waste my time. In seconds, I found my greatest common factor this way. You guys see the benefit of this? Does that make sense to you? All right. So now let's look at finding it with a variable. All right? Finding a greatest common factor with a variable. Now, I'm not suggesting you're going to use this upside down birthday cake method forever. I think you will use it sometimes. You'll use it when you need it. Like if I gave you like, 50 and 225, I don't know what that is. I would rather just say, well, I know 5 goes into both of them, right? 5 goes into that 10 times, 5 goes into that. 5 goes into 100 20 times, right? 5 goes into 200 40 times. And 5 goes into 25 5 times, 45, right? So, but 5 goes into both of these, right? 5 goes into that twice. 5 goes into this, what? 9 times. Oh, so my greatest common factor is 25. 5 times 5, greatest common factor is 25. That was really easy for me to do. It would have been harder for me to do the tree factor, right? It would have taken a long time. So that's why I like to teach that. But a lot of times I can do this stuff in my head. You know what I mean? A lot of times there'll be problems like 12 and 6. Well, I know the greatest common factor is 6, right? Now let's try it with variables. Right? Variables. So let's say I had... You're going to find variables are actually easier than numbers. They're way easier than numbers. So you guys are not loud. So x, let's say we have x squared. And we have x to the 6th. What is my greatest common factor? Yeah.
Is it x squared?
Yeah. This is why it's so easy. I'm not going to need more than one level. Because my greatest common factor, do they both have x's?
Yes.
If they both have x's, then my greatest common factor is the x with the smallest exponent.
Oh, snap.
So I only have 2 choices. That's it. It's either x squared or it's x to the 6th. That's it. Those are my only 2 options. I can't say x to the 1. I can't say x to the 3rd. I can't say x to the 4th or x to the 5th or x to the 10th. It's either x squared or x to the 6th.
The same rule applies even if 2 doesn't go into 6, or if 2 is to go into like 7.
Yeah, no, it doesn't matter. Doesn't matter because my greatest common factor is the one with the smallest exponent. So my greatest common factor is x squared. That's it. I'm done. Right? But let's just, for the fun of it, let's see what we would get here. What would x squared divided by x squared be? 1, right?
Yeah.
Right? The same thing on the top and the same thing on the bottom is going to be 1, right? So I'm going to put a 1 here. Or another way to ask it is x squared times what is equal to x squared? X squared times 1 is equal to x squared, right? Right? Makes sense, right? All right. Now the question is, what is x to the 6th divided by, oh, I don't even know if we've taught you dividing by, have we? With exponents? Oh, it's so hard. I'm sorry, I forgot about that. Okay, so we have taught, you have, sorry, this is the first time I've taught with Saxon. I always teach out of my head. And so I always teach all of these rules at the same time. I teach all these rules at the same time so that everybody has them. But I don't think you guys have learned this one yet. I'm going to teach it to you right now, really fast, okay? X squared, x to the 6 divided by x squared. This is a really cool rule. The rule says that if you have the same bases, what are the bases again? The x's, right? And they both have exponents, and you're dividing one into the other. It's this. It's the same as saying x to the 6 minus 2, which is x to the 4th.
I was right.
So if they're the same bases and you're dividing, you just subtract them. The top minus the bottom. And it works. Like what? Let's just do it the long way. X to the 6 is the same as x times x times x times x times x times x, right? X squared is x times x, right? Yes?
Yeah, cross them out.
All right. What's x over x?
1.
I can cross those out. What's x over x? I can cross those out. What do I have left? X to the 4th. So I just basically I subtracted these 2 x's from these 6 x's, and I got 4 x's, or x to the 4th. See what I mean? See what I mean? Yes.
So the x's just stay the same, and the numbers only change?
The only thing that's changing is the x stays the same, and it's the exponent that changes. It works with numbers too. Like if I did the same thing, let's say I did 3 to the 6th divided by 3 squared. Well, that's the same as 3 times 3 times 3 times 3 times 3 times 3 over 3 times 3, right? Well, what's 3 over 3 equal? 1. What's 3 over 3 equal? 1. So all I have left is 3 to the 4th power. And I could figure out what that is. 3 times 3 is 9. That's 9. That's 9. 9 times 9 is 81, right? So 3 to the 4th power would be 81. But with variables, you don't know what the x is, right? You don't know what the x stands for. It stands for something, but you don't know what. So you just have to kind of keep it as an exponent. But so if you're dividing x to the 6 divided by x squared, it's going to be x to the 6 minus 2, which is x to the 4. Now, if that still confuses you, you can use the method you do know. You know that x to the a, no wait a minute, how did I do that? X to the n times x to the m is equal to x to the n plus m, right? So x squared times x to the what would equal x to the 6. X squared times x to the 4 would have to equal x to the 6, right? So as long as you know those, it'll make sense. So now, knowing all this, I hope I'm not totally losing you guys. Am I losing you guys?
No.
Okay, good. I'm covering a lot of stuff I didn't plan on. I forgot about the fact that you hadn't learned that rule. So, now I'm going to give you a harder one, okay? 12x to the 6th minus
6x.
6x to the 4th. All right. So I want to, actually I don't need the minus sign in there right now. We will get there very soon. We'll get there. All right. How many people wrote the minus sign already? You want me to leave it? Okay, I'll leave it.
Oh, what?
Okay, I'll take it out.
No.
Okay, I'll leave it.
Yes. Leave it. No. Oh my.
All right, I'm taking it out. I'm taking it out. So now, what is my greatest common factor? First of all, to find my greatest common factor. This is important. The first thing I do, I'm going to write it in black. So I look at the numbers, and I ask, what is my greatest common factor? Okay, numbers, what is my greatest common factor? I've got a 12 and I've got a 6. I'm not looking at the exponents. I'm just looking at the 12 and the 6, my coefficients, right? Yes, Amy. 6. So 6. Whoops, wait, I got to leave my, that's okay, 6. Now I'm going to do, so 6 goes into 12 how many times? Twice. Now look, I haven't done anything to this, so I got to bring that down. You guys with me? I'm hearing a little murmuring. I'd rather you guys be quiet for me. 6 goes into 6 how many times? Once, right? But I didn't do anything to the x to the 4th, so I got to bring that down. Okay? You with me so far?
Yeah.
All right. Are there any, with the numbers, is there anything else I need to take out? 2 and 1, they're both prime numbers. I can't go any further, right? But what about the x's? Okay, so now, which of these, remember, with the variables, they're easier. I only have 2 options. It's either going to be x to the 6th or x to the 4th. That's it. Those are my only options. It's not going to be x to the 3rd or x to the 2nd. You're not changing anything. It's only either this or this. Which one is it going to be?
X to the 4th.
Are they right? Are they right?
Yeah.
See, Chloe knows, right? She does. It's x to the 4th. You got to use the one with the smallest exponent, right? And then when I do that, what do I have here? I'm still going to have the 2 because I haven't done anything to the 2. X to the 6th divided by x to the 4th is x to the 6th minus 4. X squared. All right? Right? X to the 4th. 1x to the 4th is the same as x to the 4th, right? They're the same thing. Those are the same thing. What is the same thing divided by the same thing? 1. All right. I can't go any further here. There's no number. These are prime numbers. 2 and 1. I can't go any further. 1 goes into these both, but 1 never changes anything. Right? So I can't.
I can't really see.
Sorry. So really, what is my greatest common factor? My greatest common factor is 6 times x to the 4th or 6x to the 4th. Right? Make sense? So let's try a couple a little faster now. Can I erase this?
Yes.
Yes?
No.
I'm erasing it. Look at your neighbors if you read a copy. Okay. Oh, by the way, I didn't finish this. The first thing you do is you look at your numbers. The second thing is you look at your variables. And with this, help me, variables, if both terms have same variables or same variable, then greatest common factor is the variable with what?
The smallest exponent.
Right, with the smallest exponent. That's a E.
Excuse me?
All right. So let's try a few. Let's try let's try I don't know, 32x to the 8th, and we'll do
26.
24x to the 6th. All right. So what is my greatest common factor of the numbers only? 32 and 24. What is a factor? It doesn't matter how many.
4.
So I know 4 goes into both of those, right? So let's try that. 4 times what is 32? 4 times 8, right? I'm gonna have to, I haven't touched this at all, so I'm gonna have to keep that coming down. 4 times what is 24? 4 times 6. I'm gonna have to keep my x to the 6th. All right, now my next layer, my birthday cake.
My birthday.
What goes into both 8 and 6? 2. All right. So 2 times 4 is 8. And I'm going to have to bring down my x to the 8th again. 2 times 3 is 6. And I have to bring down my x to the 6th. Am I done yet?
No.
I'm done with the numbers, aren't I? But I'm not done now with the variables. What's the greatest common factor of the variables? X to the 6th. So my greatest common factor is what? 4 times 2 is 8.
So 8 to the 6.
8x to the 6th. Pretty straightforward, right? Makes sense. Saxon is jumping really fast.
Yeah.
Right now on this topic, I think personally. But this is what I would suggest you first focus on, because this is, now let's see if we can do it without the birthday cake method, okay?
No. I like the birthday cake. Because I like how you could do it.
So yeah, but you can always use the birthday cake method. It's always there for you, always. But now let me, can I erase?
Yep, the cake is always there for you.
If you use really big numbers.
Wait, no, I didn't catch it.
Did you say no? Oh, you got it? Okay. All right.
I don't know if x to the 8th is prime or not.
What?
I don't know if x to the 8th is prime.
Yeah, so you have to just leave it like that. You can't really do anything. You know what I mean? So, now what if I gave you something like this? 3x to the 4th, and I said I'm gonna put a sign in here now.
Plus.
Are you sure, Gary?
Yes,
Are you positive?
6x squared. All right. So my greatest common factor, when they're simple like this, it's not that hard. What is my greatest common factor between the numbers? 3, right? Isn't that clear?
3x squared.
3. And what's my greatest common factor with the variables?
Oh, x squared.
X squared. So look, you just did it without a birthday cake. Right? It wasn't that hard. All right? So that's your first one. Now let's try, oh wait, what am I doing? Oh yeah, that's the greatest common factor.
Wait.
That's the greatest common factor. So now let's try another one. Let's say we have 12x to the 6th plus 18x to the 10th. I want to know what my greatest common factor is.
12x?
So does 12 go into both of these numbers?
No.
Does 12 go into 18?
No. 6.
Evenly. It's got to be evenly, right? 6 goes into 12, 6 goes into 18, right? That works. So 6, and that would give 6 times 2 and 6 times 3. Yeah. So, okay, so we're going to say 6. And then what's my greatest common factor with the x's? X to the 6. Not so hard, right?
No.
You're starting to get it. Does it make sense?
Yeah.
You writing these down, Elizabeth? Write these down. All right.
I have a question.
Question, yes.
Does it really matter what sign you put in between?
No, not right now. It will soon. It will soon. I'm
it
adding the
has to
sign.
be addition
I'm
or
adding the
subtraction.
sign because we're going to go the next step, and I think I'm going to wait and do that tomorrow. I'm just afraid. I'm afraid to teach too much today. I've already been teaching too long. So, in fact, I should probably just turn this thing off.
And then I could play math soccer.
We don't have enough time.
Tiana says hi.